Cool. So yeah, I might have a hard time looking at the chat, so feel free to unmute if I don't respond to the chat fast enough. But yeah, so, and again, if you're not a member, please use this link to sign up to get notifications about future events, and join our Discord, and check out like the rest of our social to look at past events, look at recorded workshops, reading groups, et cetera, et cetera. But yeah, let's jump right into it then. So yeah, everybody, welcome to the Intro to SQL workshop. I'm Victor. I'm a 4A computer science with data science option student here at the University of Waterloo. Yeah. So this workshop is intended for beginner data scientists. Yeah, I don't expect you to come in with any prerequisite knowledge. So yeah, and the goals for this workshop will be for you to understand the differences between common database types and providers, and write simple SQL statements to create, explore, and delete data. And for the motivation, so why should you listen to this workshop and all the way through? Well, nowadays, almost all data is used for analytics is stored in SQL databases. SQL has been like the de facto method of data storage since basically the start of data storage. And although NoSQL kind of has had a period of popularity recently due to like high scalability, SQL has also kind of caught up and is still being used as one of the most popular data storage methods. Quite often you'll be confused, like what kind of database should I use? Because there's many different types, as well as like different types of providers for a specific type of database. So by attending this workshop, you'll have a better idea as to which database you should use for a specific project. And also sometimes data needs to be transformed before loading into analytics software. So like if you're trying to build a dashboard using something like Tableau, sometimes you need to format the data or join data from different sources before it gets loaded into the software. And then you can create the dashboard from there. And also you might be thinking, oh, why do I even need a database? I can just throw everything into like a CSV file and just do that. Well, there's going to be edge cases for sure. And there's a lot of stuff that you might not think about, but will bite you in the back later down the line. So why reinvent the wheel with data storage? Just use a database that has been proven to store it in a reliable way, and just worry about the rest of your application rather than fiddling with how you store your data. So for general outline for this workshop, we'll start by discussing the different data types. So relational, document-oriented, and those kinds. Then we'll jump into the discussion of exactly SQL versus NoSQL. That's the most popular debate for different database types, and when you should use SQL databases, when you should use NoSQL. And then we'll look at, assuming you've chosen to use a SQL database, the different providers that you can use and some of the advantages and disadvantages of them. And then we'll jump into actually writing SQL statements. And so we'll begin with select from where, this kind of format, since almost like 90% of queries that you do with a SQL database will have this kind of a format. And then we'll look at joins, which are which give you so much more power, allowing you to join multiple tables and get a lot of information from that. And then we'll just conclude with how to create, insert, and delete data. So yeah, let's jump right into it. So to begin, what is a database? There's a lot of different definitions, but they all generally revolve around the concept of an organized collection of data stored on a computer system. And some of you might have heard other terms thrown around, like data warehouse or data lake. And these are a kind of database that is focused on more analytical processing. where a data warehouse is more for highly structured data, and data lake is for raw unstructured data. So like blobs of binary or just stuff that you don't really care about the format of. And usually the database will be what will be powering your application. So what is storing your current data, so like your current users, your current profiles, whereas you would put current and historical data into a warehouse or a lake, so that you can then process it and analyze that data for those purposes. And usually data warehouses are not intended to satisfy the transaction and concurrency needs of an application. So you want to use a database for that. And also data warehouses are pretty expensive. So it's another deterrent. So let's discuss the 5 main types of databases. Although like recently, a lot of database providers kind of blur the lines between them and provide many different types of databases. So sometimes like MongoDB is both document-oriented and KeyValue. And so, but these are like the 5 general frameworks of types of databases, and we'll discuss them. So we'll go into relational, document-oriented, KeyValue, wide column, and graph. So let's start with the most basic one, relational database. And when I say SQL database, I basically mean relational database. The two terms are kind of used interchangeably. And when I say NoSQL, that's literally any other kind of database, document or KeyValue or whatnot. So SQL database is a relational database. And this kind of database stores data in rows and columns. Let me try to turn on my laser pointer here. So you can see in like this kind of table, this is storing like dog. Like each row represents a different dog. So we have like a name column, we have a dry or wet food column, and then like a yes, no column. So the columns represent attributes, and then the rows represent actual individual entities. And sometimes we'll have like common columns. So you'll notice like the name column is in this table as well as in this table. And we kind of use these common columns to be able to relate tables. Although you might be asking, why do we need different tables to begin with? Why can't we just throw everything into one humongous table? Well, it's kind of hard to see in that image. So I have a different image here where here these are like the columns or attributes. So let's say we have like users table and ratings table and movies table, each with their corresponding attributes. And it might be hard to, let's say, put all the ratings for every single user, for every single movie in one table, right? And if, let's say, one movie was to be removed from the database, you would have to go through every single row, check every single rating, and see if that rating corresponds to a movie that's about to be deleted. And so by having the data separated in different rows, each can basically represent a different entity, and we can then operate on them, insert, create, and delete a lot easier. Although reading the data will be a little bit harder because we need to join the tables to be able to get information across tables. So, but anyways, and you might notice that these tables all have a predefined schema, right? So it's really hard after you've created a table and like added data to it to change the schema. And schema in this case is like the definition of like the different columns. So like in this case, like an ID is an integer and the first name and last name are like strings. It's really hard to add a column halfway through because everything is predefined. So although it does give you some benefits, like somebody can't just randomly add a row with 10,000 columns. So having a predefined schema allows you to be a little bit more structured and validate your data before you insert or delete. But of course, you get the trade-off where you lose the flexibility. And so some common relational database providers include MySQL, Microsoft SQL, and PostgreSQL. So now let's get into document-oriented database. This is the most popular NoSQL type. So instead of having, instead of having like rows and columns, we basically have documents where each document is some humongous object that basically represents something. So here we have like profiles, and each profile basically can look very different. It doesn't have a schema, and the document-oriented database is literally just a collection of these kinds of documents. So of course, you could use to query this kind of database. Each document would kind of have like a key. In this case, it would be like ID. So you could find like the documents that have a certain ID, or like find the documents that have a date of birth earlier than 2000 or something like that. So this is kind of the structure for document-oriented database. So it's schemaless, so much more flexible, and it's also a little bit more scalable because all these documents can be kind of separated. They don't have any like relationships between them. So it's, you don't have to store them in one humongous server. You can kind of spread them across different servers, which makes it a little bit more scalable. And so common providers for this kind of database is MongoDB, DynamoDB. Just check chat, okay. So another kind of database is KeyValue Database. So this is pretty similar to the document-oriented, but instead of having large document objects, we just have simple values. So although you could technically have a full document as a value, you can also have something simple as like a string or an integer. And so key-value databases are usually prioritizing speed. You can think of it just like a dictionary that you like, or hash map that you have in memory, right? You have a key, you look up its value. You have a different key, you look up that value, right? It's very key to value oriented. And it's hard to search through the values as you would do in the document oriented database. And again, part of it might be stored in memory to even more speed up the lookups. And some popular providers here are Redis and Memcached. Okay, and then we have wide column database, and this is kind of like in the middle of key value and document oriented. And it's also kind of similar to relational, where we kind of have a two-dimensional key value kind of structure. So we have the first dimension, which are kind of like the rows. So like in this case, it's Bob, Brittany, and Tori. And then in the second dimension, so for each of these, we have an object that contains columns. So we have email address, and then the corresponding values, gender and value, and then age and then value. So basically every single document is like a two-dimensional key value pair. And so again, this is similar to a relational in that you can kind of see the rows and columns, but it's a little bit more dynamic, right? You can have different length columns, different columns for different rows. And similarly, it can also be more easily distributed. And so some popular providers here are Bigtable and Apache Cassandra. And then last but not least, we also have graph databases. So this is kind of a new type of database that's pretty hot these days with like Facebook. And so this kind of database, instead of storing data in rows or columns or in documents, we store them as like nodes. And then we kind of illustrate relationships with edges. So sometimes when you're using like a SQL database or like you need a lot of joins to be able to connect the tables. Whereas here you kind of just follow the edges. So it's really easy to see relationships between documents and be able to follow them for certain types of queries. So this is obviously better for like social networking recommendation engines, and fraud detection. And some popular providers here are Neo4j and OrangoDB. But yeah, I'll take a pause right now. Are there any questions? Yes. The logo for OrangoDB is an avocado, so that's pretty neat. But yeah, cool. Doesn't look like there is any questions so far, but again, yeah, feel free to stop me at any time if you do. Who knows? So yeah, I won't get into some of the other databases, but like the main comparison that you need to make is, should I use a SQL database or a NoSQL database? Because other than like the graph database, the other three are very similar. They have like keys and then corresponding values, whether that value is a document, some value, or like a wide column thing. So in this, for the SQL versus NoSQL, you kind of have to ask yourself these 4 questions because it highly depends on your use case. So the first one is, do you want an enforced schema? Remember, SQL has an enforced schema. So before you create a table, you need to define what columns you want and how those columns will interact. So that's a trade-off of flexibility versus structure, and possible data error correction or stuff like that. And for the second question is, for the second part, do you have vertical or horizontal scaling? So SQL usually tends to do better when you're doing vertical scaling, which is like getting a better CPU, getting more RAM, aka memory, or getting a larger storage. Whereas NoSQL, since you tend to distribute your documents, it's a lot easier to distribute your documents. It's better for horizontal scaling, where you set up like multiple servers, and then each server will host like part of your database. And so depending on what kind of scaling you want or are going to implement, then you might choose a specific kind of database. Furthermore, we also have ACID transactions. So ACID stands for atomicity, consistency, isolation, and durability. So atomicity means when you have like a group of statements that all of them act as one piece. If like part of it fails, then the whole thing fails, and nothing gets executed. Consistency means when like it's the results are repeatable, right? You won't have like, oh, today this happens, tomorrow something else will happen when you have the exact same queries. Isolation has to do with when you have concurrent processes, you don't want 2 things that are happening at the same time to impact each other. And then durability is making sure that after something is successful, making sure that it actually stays in your database. So SQL is much better at providing these guarantees, these ACID guarantees, whereas NoSQL, it's a little bit harder, although recently MongoDB, which is the most common NoSQL database, has said that they are providing ACID guarantees for their most recent release. But yeah, and then we also have relationships. So with NoSQL, of course, putting graph databases aside, those are kind of separate. It's kind of hard to have relationships between documents in a NoSQL database, right? All the documents are kind of separated, especially if you're distributing them across different servers. So SQL is usually better when you have a lot of inter-table relationships and you use those in queries. Oh, I went a bit too fast. I'm losing this. Okay, cool. And then, so now assuming that you've chosen SQL, there are these 4 main providers. they are MySQL, PostgreSQL, Microsoft SQL, and Oracle. And this is in the order of least to most expensive, with MySQL and PostgreSQL being free and open source, and Microsoft SQL and Oracle being commercial, with Oracle being the more expensive option. So between MySQL and PostgreSQL, PostgreSQL actually is like a SQL NoSQL hybrid. So it gives you a little bit more flexibility, assuming you're able to actually, it's a little bit more complex, of course, using both, but it does give you that extra functionality, whereas MySQL is purely relational. And MySQL is more of the simpler provider. It's better at if you're mainly just reading data from tables and you want that to be really quick, whereas PostgreSQL is a little bit better when you want some complex functionality. It's a little bit more extensible, since it also includes like function overloading, and like it handles concurrency a little bit better. And then between Microsoft SQL and Oracle, Microsoft SQL is the easier one to use. Oracle is a little bit more flexible and a little bit more complex. So a lot of people tend to, if you want to learn both of them, you kind of want to learn Microsoft SQL first. It is slightly slower, but it still manages to do everything that the open source providers are able to do, and basically almost everything that you need anyways in a database provider. Oracle tends to handle large data a little bit better than Microsoft SQL, and it also has default transactions. So transactions being kind of similar to the ACID guarantees, making sure that when you have statements and like part of it fails due to some error, that you're able to roll back and basically undo anything that shouldn't happen. So Oracle is a little bit better at handling those kinds of guarantees and error, fault tolerance kind of stuff. But yeah, so that's, I'll take another quick break if anybody has any questions. And then we'll get into the actual learning SQL statements part of the workshop. Cool. Doesn't look like anybody has any questions. So we'll jump into the SQL portion. So if you didn't know already, SQL is the language that you use to execute statements with a relational database. And before we actually get into writing them, I basically created a database with like pre-existing data, and I kind of want to describe what the context of the data is, because you can't just have data without a context, right? So in this case, I'll have three main tables. I have the users table, the dishes table, and the products table. So as you can probably tell, it's supposed to store like recipes. Products can be like ingredients, right? So you can kind of see the attributes that each of the tables have. So users has its own identifier, a name. Dishes has an ID, instructions, and a cook time. And then products have a name, price, and ID. And I've also added like relationships. So users want to make a certain amount of dishes, and then the dishes contain some quantity of products. And this kind of diagram is called an ER diagram, an entity relationship diagram. And you'll learn how to do this in CS 348, which is the database course here at the University of Waterloo. But don't worry too much about how to create this diagram. I kind of just wanted to describe the context for our database so that we can better make our queries to reflect this. And yeah, so although I would like everybody to set up their own like MySQL database, that's infeasible. So I found this really nice online SQL compiler. So if you want to follow along on your own computer, and kind of try different SQL out, do it while I'm doing it on the screen, feel free to go to this website yourself. It's called SQLfiddle.com. And then I also have this setup. It's basically just a code paste of the basically creating all the data in a database. So I'm just going to copy this, and then let me put these two links in the chat. So SQLfiddle.com and tiny.cc/SQL schema. And then we'll go over the following. We'll go over the following SQL pieces. So once you're on SQL Fiddle, you'll take the setup code in the tiny.cc code paste and just put it in the top left here to build schema. And this will just populate the database with the data ready. And you can kind of just hide this by clicking the browser button. So you just get a cleaner view of how the tables look like and like the columns in them. I'll get back to exactly what we put in this, like the create and insert statements at the very end. We'll kind of just play around with the querying the data for now. Yeah, it's pretty cool. I actually found this out pretty recently too. Otherwise, I would have had to spin up my own MySQL database, but this is really nice, especially for a workshop. But yeah, so I'll give like a minute for people to kind of get themselves set up. And if you have any questions, feel free to put it in the chat or unmute. But yeah, just to reiterate, you take the code in the tiny.cc link and copy and paste into the top left text box here in the fiddle. And then you click the build schema button here. Cool. So doesn't seem like anybody has any problems, but if you do, again, post in the chat, but we'll get started at actually running some SQL statements. So you'll notice that I have 5 tables here. The 3 of them that I kind of discussed, dishes, products, and users. I'll kind of get into what the other 2 tables are later, but so let's just take a look at the 3 main tables. So again, the most common query format is select something. In this case, it would be column names, and then from, and this will be table name, and then where, and then condition, semicolon for delimiting. And so in this case, we're going to select everything. So that'll you start to select all columns, and then from, let's say, the dishes table. And then let's just omit the where clause for now. So this will be basically just select everything from the dishes table. And then when we run this, assuming it runs, yeah. So this is what the dishes table look like. We have this ID column, we have the name column, names of the dishes, and then a list of instructions, and then the cook time. Put the cook time in minutes just to make it a little bit simpler. And then, so yeah, and then of course we can add the where clause back. So let's say where cook time is less than 20, right? Let's just say we want to find all the dishes that you can cook in less than 20 minutes, right? And then we can execute this, and then it's being very slow for some reason. Let me try refreshing the page. Okay, let me do where cook time is less than 20. Cool. Okay, I just had to refresh the page. But yeah, so now you'll notice we have our table back, but we only have one row now, because this is the only dish that has a cook time of less than 15 minutes. And again, we can replace the star with the columns that we want. Let's say we just want the name and the instructions, right? So we can do dname and instructions. So comma separating the columns. So you can see in the resulting table that we have 2 columns and still filtered by cook time less than 20, right? And yeah, this kind of syntax is half of like what's the recommended syntax and half of just like my own conventions. So like you tend to have SQL keywords in capitalized letters, and then custom names such as like columns, table names is usually in lowercase with like underscores. And you can do like 1 bit per line, but it's all up to you. It will still work if you do it lowercase. SQL doesn't really care when it comes to uppercase or lowercase. Yeah, I don't know why it's being so slow. It's gonna be slightly annoying. But yeah, anyway, it still works if it's lowercase or capitalized, but I tend to like it keeping keywords capitalized. So we can also look at some of the other tables as well. So let me put users here instead. So this is the users table. It has an ID column and a name column, and then we can look at the products table. I don't know. I don't know if any of you guys are also doing this on SQL Fiddler as well, but I'm not sure why it's being so like, I don't know if the rest of you are also running into. Cool. I mean, it is hosted somewhere online, so it just might be whatever the server hosting it is having some issues, but it looks like it's working for other people. So yeah, if it keeps on happening, I'll just switch to a local instance of MySQL. But anyway, cool. So, but yeah, just feel free to just refresh it if it ever gets slow. But what we're doing, oh yeah, we were doing products. So products is this table, right? PID, ID, the name of the ingredient, and the price. I have the price in cents also, just to make it kind of simple. So we don't work with decimals. But anyways, so notice that select will, yeah, okay, so that's select. What was I going? Oh yeah, as. So I can, like, some of these names, the column names, we can actually give them aliases, right? So, and I could do a PID as identifier, and then pname as ingredient, right? And then that will just rename the columns. And you can also rename the table name as well if you want. We'll kind of see how that impacts it later on. But you use the as keyword for aliasing. And I mean, one thing that I find really nice with SQL is it's really like English, really close to English, right? You can kind of think of it as selecting this column as this name, this column as this name from this table where some condition, right? It's not too hard to kind of see and kind of write it out because it's pretty close to English. But anyways, so now let's actually get into joining tables because that's where all the fun happens in SQL. So let's actually look at the dishes products table. And so what this table is it has 3 columns. The first column corresponds to some dish identifier. The second column corresponds to the identifier of a product. And the third column is just the quantity. So you can kind of think of this as dish 1 contains 2 of this ingredient, of ingredient number 11, right? And the same, dish 1 contains 1 of ingredient number 12. So this is kind of like an intermediary table that we'll use to join the dishes table and the products table. So we're going to try to answer the question of, or like try to produce a table with both the dishes and the ingredients. So how we join tables is using, you guessed it, the join keyword. So we can do select star from dishes. We'll put dishes back here. So the dishes table, join on the dishes products table, and join requires a join condition. And so remember that both the dishes table has and the dishes products table has this DID column. So we'll say on dishes dot, use the dot to get a column from a table. So the DID column of the dishes column, dishes table. This is equal to the dishes products dot DID. So the DID column of the dishes table is equal to the DID column of the dishes products table. And if we run this, also for those of you who are actually writing this out yourself, feel free to slow me down if I'm going a little bit too fast, because I have quite a bit of experience in this, and some of you guys might type slowly. So feel free to slow me down if that's an issue. Another refresh. So if you run this, you'll get this really large table. So what this did is basically takes everywhere where the DIDs match, we stick all the stuff in the dishes table and everything in the dishes products table for that corresponding row. So spring rolls is repeated this many times because the DID, the identifier is 1 for quite a lot of the dishes products table as well, right? And so it's a little bit hard to think about it or understand it the first time you see join, because it's a little bit confusing at times. But you can kind of think of just, you literally go down the 2 columns, the DID column of the dishes table and the DID column of the dishes products table, and every single place there's a match, you copy that row, and then you join them together as one humongously long row, right? And so notice here the DIDs there's only 1, 2, and 3, the spring rolls, carbonara, and the corn on the cob. But if we go back to just looking at the dishes table, you'll notice there's actually 4 dishes here. And the reason why we don't see them in the join table is because like if we just look at the dishes products table, DID equals to 4 doesn't show up in this column at all, right? So there's no place where pizza will be joined with any row in the dishes products table, and that's why you don't see it, right? And so yes, David is correct. This is an inner join, and inner, I could put inner here, but it's basically the same. Inner means anything that only shows up in one table and not in the other table you just omit, right? So in this join table, we don't see pizza anywhere in this table. But if we wanted to keep pizza, we can do what's called a left join. And left join basically takes all the common pairs in the dishes table and the dishes products table, as well as anything that's in the dishes table that might not appear in the dishes products table. So if I run this now, I have to stop highlighting stuff. So now you'll see at the very bottom here is DID 4. We have pizza here, but the corresponding columns in the dishes products table from the dishes products table are just all null, right? Because there's no corresponding row, no place that it can match, right? So that's the two most common types of joins. You can also have right join, but this is not very popular because you could literally just change the order of the tables and then just use a left join, right? Because it just uses whatever table is first. And then there's also outer join, which doesn't actually work in MySQL. Right now we're using MySQL. If you see in the top left corner here, because outer join is kind of funky. And what it's supposed to do though is anything that, so you have all the pairs that match and anything in the left table that doesn't appear in the right, as well as anything in the right table that doesn't appear in the left, right? So kind of the opposite of inner join. Rather than intersection, it's a union of like everything. So it can get a little bit messy. And MySQL actually doesn't even allow outer join. So yeah, but you probably won't really need outer join much, just inner and left. But yeah, so although right now this table still doesn't look very useful, right? We still have this PID column here, right? We want to get a little bit more information from the products, right? So we'll join this humongous table on this PID column with the PID column of the products page, right? And then we'll have that information as well. So we'll left join this with the products table on dishes products dot PID is equal to products dot PID. So this basically forms one new table, and then we're joining that humongous table with the products table on this condition. And if we run this, assuming it runs, now we have a more complete picture of what our database contains. So we have this row is, we basically have a row for every single ingredient in every single dish. And we have both the dish name, the dish instructions, the cook time, the quantity, the ingredient name, as well as the ingredient price, right? And like these DID columns are a little bit redundant, so, and don't really provide any more information. So we can kind of just omit them. Let's say we just want the name, quantity, MP name, right? So if we run this, we get basically, yeah, so spring rolls contains 2 garlic cloves. Spring rolls contains 1 ground pork. It contains 6 shiitake mushrooms. We have pizza with no information. Remember, because there's no pizza in the dishes products table. So this is not really useful anymore. So we could either change the left joins back into regular joins, or if we just do like where products dot p name is not null. I think this works. And then that will also just remove it. So we can also filter it like that. And then, yeah, so yeah, carbonara contains 5 ketchup, corn on the cob contains 1 corn. But yeah, so this just shows the power of join. We're able to, although like the data is kind of separated in all these different tables, we're able to join the tables and then have a much better picture of what exactly is going on in our database, and then be able to analyze it for whatever use, right? And then, okay, so let's put price back in here. So we can look at the prices as well. And let's say I want to find the total price of a dish, right? So like spring rolls contains all these ingredients. I want to get the total price of how much it would cost me to make spring rolls, right? Assuming these prices, right? So what we can do are what are called aggregation functions. So example would be sum. So we could do sum of price, right? And you do this on the column, right? So we're basically saying, take the price column and then aggregate it using the sum function, right? Although if you do run this, you'll notice we only get one result back. And that's because sum will literally take every single price and add it together. We don't really want that. We want only as many as that correspond to that, that recipe, right? So what we can actually do is called GroupBy. And then we'll put in the column name that we want to group it by. And of course, you need to remove the other attributes because we're not grouping by those. And that will actually cause conflicts because it doesn't know which quantity to use. So now that I have GroupBy here, we can see that we have carbonara costs $3.53, corn costs $1.05, spring rolls costs a whopping $28. And so that's all great. But again, this is not assuming quantity, right? We just sum the price. So we could do quantity times sum of price, right? And then this will give us a little bit better. Now spring rolls cost a full $56. But so group by needs to come after the select from where. I'm pretty sure if you put the group by before the where, it won't work. Yeah, so it comes after where. So from, it's like select and then column names, that stuff, and then from and joins go together. So like from and then like your whole joining shenanigans, then where all your where the conditions group by. So yeah, this order needs to be like that. And then we can also have like order by if we want to put this in like descending order. So we can do order by dname in descending order. And I think order by also needs to stay after group by. If I try to run this. Yeah, so this order is you have to abide by this order, but otherwise, yeah. Cool. And then we could also, so if I go back to this, so we have this, and then notice that this is itself a table, right? So we could nest this in another select from, right? And then just wrap this all in parentheses. Because this is itself a table, right? So we can select from it. Get it? If I do, so this is spring rolls is $56. Order by dname descending order. Yeah, well, spring rolls is now at the top. It's still $56. I just reordered them. So the top is at the top, and the top is at the bottom, and the bottom is at the top. Okay. Cool. But anyways, so yeah, back to the select. We can do from this humongous table. And let's just say we want to filter this table by where, now this quantity times some price, you'll notice it actually just shows up in this column name, and it's not very nice, right? So we can alias this as total price. Right, so now we want to select everything from this table where total price is less than, let's say 1,000, right? We should only get corn on the cob in this case. But if you run this, yeah, we need an alias. So because this humongous table doesn't actually have a name, so we need to give it a name. So let's just say this is priced dishes. So give that a name, and then, yep, we get the resulting one row with corn on the cob being the only dish under $10. And it's, yeah, so you can see the power of just being able to write some SQL, being able to find out a lot about the database. So yeah, and again, select always returns a table. I mean, in fact, we could just do select one, right? And you would expect it just gives you one back, but not necessarily. It gives you one, but in table form, right? We can even alias this as my one, right? And it's literally a table that contains one row, which has one, and that column is aliased as my one, right? So select always return the table, regardless of what it is you're actually returning. Because it's literally, because this one is literally just a column. It's just saying, I want a column of ones. And we could do, so let's get rid of that. We could go back to this one here and just do like, add a column just as one, right? And this will literally add a column of ones to our table, right? Because the value is one. Whereas these values are computed with the formula. And again, the formulas, these operations are all column-wise. You can't do row-wise operations, except for like aggregations kind of do it row-wise, but the parameters are always columns, right? You can do column times column, column plus column. You could do 3 times this, whatever you want, as long as you're only operating on columns, because this is selecting from columns. You need these are just the columns. But yeah. Cool. So it looks like there's let me just go back to, wait, where's my speaker notes? But yeah, so I have a few okay, my tabs are being hidden by this Zoom thing. Let me move this down here. That's not what I wanted. So I'll go into explaining the schema on the left, but for those of you who want some challenge questions, feel free to attempt these problems. So the first one is finding the total price of all meals that each person wants to make. Remember, because we have a users table, and a users dishes. So you can kind of think about how you would connect those with what we have currently. There is average cook time for the meals that Victor, wants to make. So obviously you can do sum, you can do average, you can do min, you can do max. These are all aggregation functions that you can use. So average cook time for meals that I want to make. And then we also have one which is a little bit more harder. How many times is tomato ketchup used in recipes that take less than 20 minutes to make? So feel free to take these challenges and on your own time, try to figure them out. And if you have solutions or you want to check in, can ping me on Discord, or we have the workshops channel in our Discord. So feel free to post your ideas in there. I'll just put these in the chat so you have access to them. But yeah, so for those of you who want to get into actually creating data or that fun stuff, we'll get into the actual schema creation. So again, the syntax is pretty simple to read, right? We want to create a table called users, and you have to specify table here because you can actually create a number of different things. You can create tables, you can create databases, you can create roles, you can create users, you can create views, a lot of different things. And that's a little bit too advanced for this workshop. But so for now, we're all just creating tables. but feel free to explore all the other fun stuff that you can create. So here we're creating a table called users, and in the parentheses that follow it are the column names. Remember that SQL is schema enforced, right? You need to define the schema before you actually start interacting with the table. So here we have two columns. Let me just actually just select from the users table so we can kind of see how it looks like. And I'll put that back. So again, UID column of ints and the name column of strings, right? So we have a UID, and then you have the data type, right? Data type could be a lot of different data types, and it highly depends on what provider you're using. So although the most common ones are
to have the stickers that you're supposed to have.
Sorry, was that a question? Could you repeat that?
Oh, sorry. I mean to talk.
Okay. Cool. So, yeah, so different data types. You can have int, varchar is for a string. This is saying I want a 255 length string, or at least up to that length. And then you can also have decimal for ones that actually have like a fixed number of decimals. There's float, there's date, there's time, there's byte, there's so yeah, those are like the most common data types that you can use. Yeah, we'll get into auto increment, but those are the different types of data types. And then we have not null, which is, as it kind of says, not null, right? We don't really want any rows in our users column to have a null ID, right? Because the ID is supposed to represent that row, right? So that's why we're kind of enforcing that this column cannot have any nulls in it. If you try to insert a row that has null for this column, it'll actually reject it and say, nope, you can't do that. There's a not null constraint in place. And then for auto increment, you'll notice that in this table, the IDs just increase by 1, and it's just 1, 2, 3, and it literally counts up until it runs out of space. And so that's what auto increment does. So rather than when I'm adding, inserting rows into this table, I don't actually have to specify the ID column because it's auto increment. So it will automatically add 1, 2, 3. And as I insert more, it will literally just continue counting by taking the last one that was added and just incrementing it by 1. So that's what auto increment does. It's kind of like a quality of life thing, so that you don't have to specify the ID every single time, as long as you don't need to manually manage the ID. And if you do delete like partway through the table, so like it goes like 1, 2, 3, 6, 7, it will still just take the very last ID and just increment it, and then you get 8, 9, 10. So you do lose IDs in the middle if you do delete them, but that's usually not an issue. But if it is an issue, you probably don't want to auto increment here, and you want to add the ID yourself when you're inserting and manage it like that. So that's what auto increment does. If you have, hope that was clear. If you still have any questions, feel free to ask. But yeah, so that's ID. And then name, kind of similar. It's the column name is uname. It's a string of length 255, and it cannot be null. And then we have primary key UID. So this is also a constraint that I'm adding, and it's saying that no UIDs could be duplicate, right? So every single row can be uniquely identified through this one column, right? So if I give UID equals 5, that should correspond to only one row, one and only one row, assuming that we get to that point. We actually have more than at least 5 entries in the table. So although it's kind of redundant with the auto increment, because the auto increment kind of does it for us, but it is a constraint that that helps you make sure that you don't accidentally have like two users with the same ID, because that would cause problems down the line, right? So that's what the primary key does. And it also does some other advanced things like indexing to help it help SQL or the provider be able to search by ID a little bit better, but that's a little bit too advanced. So for the time being, it's mainly just used as a constraint to make sure there's no duplicates. And then, yeah, it's kind of similar for products, right? We have PID, which is an int, not null, auto increment. All the IDs are going to be like this. And then a name, which is a string, not null. Price is an int. Although technically we could do like decimal. Let's just say 10 and 2. And that would be like, we have a 10-digit price and 2 decimal digits, right? Because prices are always going to be some number of digits dot some number, 2 cents, 2 digits of cents, right? But I'm just doing them as int just for simplicity here. And again, primary key on the PID, because that's the unique identifier. Same thing with dishes. I won't really go much into that. Instructions, I kind of put a much bigger character count here, because obviously instructions can be a lot larger. And then dishes products here, we have DID and PID. Notice these are not auto increment, because I actually need to manually specify which IDs correspond to which PIDs, right? We don't just automatically have every single dish containing every single ingredient, right? So that's why these are not auto increment. And then we also have quantity. And then here we have primary key, DID, and PID. So what this means is, instead of just having one column be the unique identifier, I now have a pair. So this means that, so I won't have any 2 rows with the exact same DID and PID column, right? And then I also have foreign key. So this means that the DID column of this table references the DID column of the dishes table. So I can't have, if like the dishes there's only 4 dishes and DID only goes out to 4, I cannot add DID equals to 5 to this table, because I have this constraint here saying that it references that column. But yeah, so you can do a lot of stuff with these constraints to make sure that your data always conforms to how you want it to conform. And nobody can sneakily add random rows that can mess up your data. So it's always good to think about how you want to organize your data before you actually start using it. And then the users dishes is kind of similar. Yeah, so we're already mostly over time. So I just quickly go over insert into, again, pretty self-explanatory, into the table name. And then in parentheses, you specify the column names. Remember, UID is optional because I already have auto increment. So I just have uname here, and then I specify the values, right? And it's kind of similar for the products, where I have pname and price. And you can kind of just take this. Does DID, PID mean that you can have a row? Yes, so you could have that. So DID equals 1 and PID equals 1 in one row, and then DID equals 1 and PID equals 2 in another row. That would work. It's just you can't have the exact same of both in 2 different rows. So like if I just look at, okay, let me build the schema, and I do select star from dishes products. Right, I have a lot of DID equals to 1 and PID will have to be different, right? I can't have like DID equals 1 and PID equals 11 in 2 rows, right? And this obviously conforms to my schema. So that's why you don't see any duplicate of both these 2 columns, right? But yes, you can have one column be duplicated as long as you make sure that you have it in this syntax, right? So this obviously is very different from if I do this twice, right? Because now this is saying this column is unique identifier and this column is also a unique identifier. And this is actually not possible because primary key, you can only have one primary key. So you can, there's a separate, I forget what it is, but you can do another kind of key here. But yeah, so that's very different. So when you have this with in this kind of syntax with a comma separating the two in one line, then it means as a pair. So you can't have duplicate that pair, but you can duplicate the individual columns. Hope that answers your question. And yeah, feel free to play with it. And SQL Fiddle will tell you that doesn't work. You can't do that if you mess up. So that's that. But yeah, so that's basically it. We'll just wrap up the presentation here. Well, I've got and or, but if you didn't realize, you could do like where this is not null and total price. Oh, this is that. So let's say quantity is less than 5. Or you could do or here, but that's just part of the condition. So it's and you can kind of look at the documentation if you're ever curious about any of the keywords. So here are some further resources. I'll be sharing these slides with everyone after in the Discord, so you don't have to copy all these by hand. So these are just 2 tutorials on more SQL keywords, what you can do with SQL. On HackerRank, if you don't know already, you can do SQL challenges, just like you would do like algorithm questions. And then here are the 4 documentations for the 4 popular SQL providers. So each of them you can look up exactly how you can write SQL, because each provider has slightly different syntax. It's like some will have the outer keyword, some won't. So it highly depends on which one you're using. So feel free to check out these documentations, especially if you're going to use them for a specific project. But yeah, and also, yeah, so thanks for coming. Thanks for staying all the way until the very end. I hope it was insightful. Again, make sure to sign up if you haven't already. And we are doing a raffle at the end of the term. If you fill out the feedback form, you'll be entered to win an Amazon gift card. So make sure to fill out the forms, and I'll post all these links in the Discord. And yeah, so this recording will also be uploaded to YouTube later. So yeah, if there aren't any further questions, I'll stop the recording here. How much more SQL do you need to know to take on lead code easily? I'm not sure. I think what we covered in this workshop should be most of what you need, because yeah, everything else is kind of pretty advanced stuff. So I think this should be enough, but I wouldn't know because I haven't actually done any of them.